Yes, I am the founder, director of the Peña Rondalia. The group was officially recognized as one of the performing groups in October 2001 of the Philippine Normal University, the National Center for Teacher Education. Membership is comprised of Peña students, majority of which are taking BSc major in music, and a handful taking other areas of specialization, and selected alumni of the Peña Rondalia. The following discussions are based on my personal account of almost 25 years experience of handling Rondalia classes and Rondalia performing groups, and also feedbacks from Rondalia students and members, peers, co-Rondalia trainers, conductors, and reading and also research. Before I continue with my discussion, let me review the parts of the basic instruments of the Rondalia. Okay? Those are the basic parts, the nut, okay, and then the guitar, and then the bass. The plectrum, a triangular-shaped device used for plucking the strings. It is usually made of hard plastic, but the turtle pawikan shell is the best material for its durability. It produces bright and clear tones according to Kulig. Turtle shells are usually thick, and in the process of plectrum making, these are thinned down with sandpaper or fine broken glasses. Common synthetic picks are available, which are much cheaper and readily available at music stores. These are also good, but are inferior when compared to the authentic pawikan shell plectrums. Testing the quality of the instrument. According to Kulig, in her master's thesis at the University of the Philippines in 1995, entitled "The Philippine Bandurria, a Study on its Educational and Artistic Possibilities," the quality of the finished Philippine Bandurria is tested with the following criteria. Number 1, accuracy of pitch, tone quality, efficiency of the tuning device, resonance, and lightness of the touch. She mentioned that aside from being a part of our cultural heritage, the bandurria with its beautiful sound and unique tone colors can be a source of musical enjoyment. However, in most instances, its full musical potential is not achieved due to faulty constructions, among other reasons. The quality of the instrument is directly affected by the following factors, as Kulig has found out in her study. She said that there is a dearth of good quality bandurria in the market. Some imperfections that she found out are as follows: unproportional frets, thereby producing tones which are not in pitch; too high bridges, which cause difficulty in pressing the strings; loose pegs, resulting in lower tunings; irregularly notched nuts, which bring about rough tremolos; half-dried soundboards causing poor resonance. Intonation. Things that can cause poor intonation. The following factors that will be discussed under this heading, I believe, have also bearing on the accuracy of pitch, tone quality, efficiency of tuning device, resonance or lightness of touch. These are the criteria of a quality Rondalia instrument made mention by Kulig in her work. However, there are other factors I believe that are not mentioned in this discussion because of lack of space and time. One common tuning complaint is having to repeatedly tune an instrument. It can be tuned and it will play in tune-up, down and down the neck, but it requires frequent retuning. The causes might be the following: string stretch. New strings require stretching and take time to settle in. A string can be sour and incapable of producing correct pitches, especially when it is old and well worn. String slippage. When string tension is lost through string slippage, retuning is required. Slippage can occur for reasons such as string binding in the knot, strings poorly wound around tuning post, badly worn tuning machines, this involves the mechanical peg box. It is a tuning device with pegs, screws, and metal rods. It is made of stainless steels with plastic pegs. The gears and mechanism of the tuning machines can be flawed or worn, or the strings can be poorly attached at one of the end. Wear on the strings contact points, the frets, nuts, and saddle. Instruments themselves can be made improperly, so that all music is significantly out of tune because of the position of the nut, saddle, or fret is incorrect. Let's go to the nut. It is a white bar-shaped material dividing the head and the fingerboard, as was shown earlier. It is notched for the number of strings it has to carry. It is commonly made of hard plastic, brass, corian, graphite, stainless steel, or other medium-hard material. But according to some craftsmen, dried carabao leg bone or dried pig leg bone is ideal, although more difficult to prepare. They are harder and more solid, thereby facilitating the resonance of the strings. The more expensive ivory may be utilized for special banduya nuts. Its grooves guide the strings in onto the fretboard, giving consistent lateral string placement. It is one of the endpoints of the string's vibrating length. It must be accurately cut, or it can contribute to tuning problems due to string slippage or string buzz. Wear and grooves. The grooves of the knot will wear as the strings pass over them. As the strings pull to and fro across the knot and back piece or the saddle, they are slowly but surely deepening the groove. Excessive wear in the knot slots may cause the strings to buzz when played open, since they are now too close to the frets. Number 4, these are the causes for poor intonation. Number 4, very tall frets. 5, high action, too much distance between the fret and string. Let's go to the fret. Frets are elongated metal bars which are embedded in the slots of the fingerboard to mark the distances of tones. These are made of bronze. There are available frets sold at some hardware music stores. In case of their unavailability, the thin bronze welding rod can be improvised to form into frets as done by some. This is done by heating the rod on fire and afterwards flattening it with a hammer. The bottom portions of these frets are then formed with irregular teeth-like edges so that this can be permanently embedded on the fingerboard. The height of these frets should be exactly uniform for evenness of touch. It is easy to understand how frets become too low. It usually starts with the wear under the unwound strings. In the low position especially, the first and second strings cut into frets much faster than the wound strings because they're sharper as they rub against the frets. And they're steel, which is much harder than the fret wire. The wound strings have bronze, brass, or nickel alloy winding, which are much softer than the steel, so they tend to do little damage to the frets. Number 4, these frets are worn under all the strings all the way across the lower picture. As frets become worn, they begin to be uneven in height, and eventually they cause buzzing and other difficulties such as dulling of the tone. A temptation among both players and luthiers is to save effort and money by leveling worn frets. And many times, this works quite well. If, however, the frets are quite worn, leveling them will bring all of them to the height of the lowest worn spot, resulting in low frets. You can level the worn frets, but you might end up with poor playability because they all become too low. Wear isn't the only cause of uneven frets. Sometimes a fret will be too low because it just isn't seated properly or becomes loose with time, age, or fingerboard shrinkage caused by dryness. A fret may be too low because of being tapped too hard during installation or being injured when the instrument tips out of its stand and falls against a hard object. High frets can be tapped down and sometimes glued in position, and low frets can be raised or replaced with taller ones. If there are lots of loose and uneven frets, then it's generally best to refret the instrument to avoid excessive leveling. If you look under the straight edge in you'll see that, the previous one, please. Okay. If you look at the lower picture, if you look at the straight edge on this photo, you'll see that the fret has a nice rounded top. A straight edge really aids in viewing the profile of a fret. It casts shadows that really highlight the rounded shape of the fret crown. This nice, tall, rounded fret will be good contact for the string. The top of this fret is completely flat from excessive leveling without recrowning. Sorry, I forgot the picture. Sorry. Okay, sorry. Round.
Hindi ba yung previous flat? Previous slide.
Yeah, that one. Okay, sorry. The top of this fret is completely flat from excessive leveling without recrowning or rounding the top afterward. It's no coincidence that flat frets and low frets are often one and the same because they have the same cause. The effect of flat frets is that the string can't get a single point of contact, so it may actually flap against the flat tops of the frets, causing a dull or fuzzy tone. Add that bit of nastiness to the fact that low frets make fretting difficult, and you have a couple of good reasons for replacing the frets. Flat frets don't allow the string to make contact in the center of the fret, so intonation is likely to suffer as well. Intonation is another casualty of the low fret syndrome, as the player presses so hard that the string stretches sideways a bit from lack of control brought on by all that effort. Frets need to be perfectly level and have a nicely formed crown. Frets of inconsistent height can cause buzzing, also known as fretting out. Worn or flattened fret crowns can affect intonation and cause buzzing. Worn frets can be leveled and dressed only if sufficient fret height remains to permit filing. Fret wear. Frets that are badly grooved or have flat crowns will also throw off intonation as the string's length is changed. Correction. Worn frets can be leveled and recrowned to remove the grooves. Severely worn frets may require replacement. Fret height. Instrument with very tall fret wire can play incredibly sharp if the string is fretted hard. Using an electronic tuner fret, a note and match the tuner as you apply more or less pressure to the string to view the effects. To correct this, if the fret crown is very tall, fret leveling and recrowning can reduce its height. Playing technique. Some players, the causes of poor intonation can be playing technique. Some players have a rather powerful fretting technique in which they can place excessive pressure on the strings when fretting. If the instrument happens to have fairly tall frets, the combination often results in sharp intonation. Next, vulnerability of instrument to weather change. This can cause also poor intonation. During environmental changes, when sunlight, stage lighting, air currents, and various thermal and humidity changes are impacting a wooden instrument, the hardwood, softwood, bone, metal, and plastic parts of the instrument, tuners, and strings themselves can expand and contract or absorb moisture differently and cause all sorts of tuning problems. Playing in sunlight or in front of a heat source like a fire can wreak havoc with tuning, since the back of the instrument or even the back of the strings may be in the shade, or even worse, there may be intermittent lighting or heating that causes non-stop fluctuations. Hot, dry environments tend to cause wood to shrink, and changes in humidity or temperature, such as heating or cooling systems in a building, or sun and clouds alternating outdoors, will cause instability in keeping an instrument in tune. The neck angle can be wrong, which can cause problems in intonation. And if the action height of the strings above the fingerboard is too high, it can cause the strings to stretch out of tune as they are pressed down, especially on the higher frets. Other problems can be things that I have encountered: installation or upkeep of instruments, lack of proper storage, and the students have got to be taught the correct way of preserving the strings and physical structure of the instrument. Storage. It is usually best to store the instrument in the case. Not only does it protect from damage, the case can offer more protection from severe sudden environmental changes. Conclusion. So the things that can cause poor intonation are string stretch, string slippage, wear on strings contact points such as the nut, which can be poorly constructed, wear in the groups, then the fret, very tall frets, fret wear, the playing techniques, and vulnerability of the instrument to weather change. Recommendation. Again, Kulig recommends in her thesis that in order to uplift the standard of bandurria making, it will be helpful for craftsmen to be aware of the musical requisites which the instrument should be capable of realizing. Kulig added that according to the instrument makers, craftsmen, that she interviewed, most bandurria makers traditionally follow a pattern which serves as their model for the distances of slots on the fingerboard. They must have obtained it from craftsmen who taught them the art of making the instrument. Without further questioning, they loyally patterned their fingerboard slots on their model and may have overlooked the principle which lies behind the distancing of frets. But there are also those, the enlightened craftsmen, who apply the principle established by Pythagoras during medieval period. It is also consistent with the ratio of the octave of the Pythagorean hammers. She suggested that an easier procedure for spacing frets on the neck of fretted instrument was suggested in a book by Bessarov. The title is Ancient European Musical Instruments. This is how to do it. Number one, the measuring of the frets. Measure exactly the length of the vibrating string between the nut and the bridge. Number two, divide the length into 18 parts and place the first fret 1/18 part away from the nut. Third step, measure the distance from the first fret to the bridge. Divide the shorter length again into 18 parts and place the second fret 1/18 part away from the first fret. Repeat the same operation with the remaining frets. As a result, frets will be spaced closer and closer as they recede or move away from the knot. Frets placed according to this rule will give a scale very closely approaching the tempered scale. If this process according to Kulig will be applied on the Philippine bandurria, the length of the vibrating string is measured between the first bar after the knot on which the strings lay and on the bridge. It is also important to note that sometimes, even after the slots have been carefully placed on a scientific and practical basis, the intonation of the instrument is still affected with the thickness of strings and the manner of finger pressing. Okay, that's the end of my presentation.